everybody. I am making a video to SyberMath's problem. He posted that 2 days ago, and this is the problem. Let me explain to you guys briefly, and I hope SyberMath could check this out. The problem is this: we have an infinite series which is repeating itself for infinity times. And usually when we encounter this kind of problem, which it is repeating the function itself, we can let the whole function equal to x. And when we do this, we can say that this part, let me use another color, this part right here is actually the same because it is looping infinite times, so it doesn't matter for how many times it loops, it is just infinity. So we can also say this part right here is equal to x, and now this problem becomes easy. A simple quadratic where we multiply everything by x, we get something like this, and then let me write that down for you. We multiply everything by x, and then we move everything to same side. We end up getting this, and this is a simple quadratic which is factorable. It is a factorable trinomial, which can be x minus 1, x minus 2 is equal to 0. So what it means is x can be 1 or x can be 2. And now let's refer back here. It is impossible, right? Why an expression could have two answers? And now that's the point. SyberMath asks us which one is the correct answer, 1 or 2. And when I first see that, I think it would be a very hard problem, which involves very hard advanced level math. But after I asked my teacher, I think I could solve it. When we encounter this kind of problem, which is looping itself for infinite times, we can check the partial value of the expression itself. What do I mean? Let's check this out. 3 minus 2, let me rewrite the whole expression. And after infinity times, the function should stop, right? 3 should stop with this. Of course, it keeps going on and never stops, but we can imagine, what if after infinity times the bottom would be like this, right? That's our partial value, and that's this right here is same as 2 and 1 over 3, right? So let's see. Now our function is 3 minus 2 over x. Every time we loop this, let's see. The first time we do 3 minus 2 over 3, we get 2 and 1/3. And then this is our new x. We substitute that in. What we get? 2 to the 2 and 1/3 is same as 7 divided by 3, and then that's our new x. We substitute that in, so that we have our second iteration. Let us find the value, and then we use 3 to minus the whole thing. This right here is 7 over 15, which is same as 2 and 1 over 7. So that is our new x. We do the same thing, right? let's use 2 to divide this answer and use 3 to minus this. It is 15. It is 31 over 15, which is same as 2 and 1 over 15. So now we can see the pattern. When it is iterating with this formula, it of course have a pattern. And what's the pattern? The pattern. Let's consider the denominator 3, 7, and 15. Because other they all have 2 and a 1 over something, so no need to care about them. Just focus on what is different. 3, 7, and 15, they are actually series of 2 to the n minus 1. Can you see that? When n is 2, it is 3. When n is 3, it is 7. When n is 4, it is 15. So this is our series. And let's refer back to here. Actually, what it is doing is to get smaller and smaller. Smaller and smaller. Can you see that? With the series of 2 plus 1 over 2n minus 1. That's our series. And now, n is the times of how many times we are going to loop it. And now, for sure, we are looping it for infinity times. So it becomes a limit. The limit, as n is going to infinity, 2 plus 1 over 2n minus 1. And now we have a constant. We can just swap it and becomes like this. And this is much more simple, right? When n is infinity, the denominator becomes infinity because it is getting so big. And when we have something over infinity, it converges to 0. So we can say the limit right here is 2 because this part right here is 0, and then we have a 2. So our conclusion is that if we keep on going, we will end up getting a simple 2 after infinity times, because the limit right here converges to 0. So we can already find our answer. At the beginning, we are focusing at this part, and we find out that it converges to 2, so that our problem is now 3 minus 2 over 2, which is 3 minus 1, and it is indeed a 2. So SyberMath, I will pick 2 as my answer. And thanks everyone to watch this video. It is a fun math problem. Credits to SyberMath for raising this problem. Thank you for watching.